My name is Alessandro Barbieri. At Arista, I work in the product management team, looking after all the zero trust networking initiatives and projects. And today I'm going to talk about segmentation, which is also a new solution, new product we just released to market, and we're having tremendous traction with our customers. Specifically, today I'm going to talk about what we call multi-domain segmentation, continuing the vein that we started off with CloudVision as a tool to manage the entire enterprise network from the smallest branch to the largest data center. This is really a product that is focusing on delivering a microsegmentation services, if I want to sort of frame it and contextualize it with something you may guys know. But we actually have a very different or a very new spin on how we deliver this service. And our focus is all about operation, meaning we may not deliver something that you have never heard before or never seen before, but the way we do it is definitely a unique approach. In what way? Today, on this picture here, on this slide, I have the two most popular way of delivering microsegmentation services from an enforcement point of view. And again, there are no companies, no names, but again, I'm trying to bucketize as switch-based technologies, right? And every single sort of competitor of Arista has this solution for maybe 10 years in the market, right? And the host-based firewall technology, 10, 15 years of development. Again, so we're coming in with this landscape, what can we do better? So if I look at the switch-based technology, which are actually where we exist, where this is also what we sell network infrastructure. What are the pros and cons of this segmentation technology? If you notice how they're delivered to the market, number one, they're extremely fragmented. There's a set of technology for campus, a set of technology for data center. There are different stacks, data plane, control plane, management plane, orchestration plane. Sometimes they talk to each other. Sometimes they don't even talk to each other. And the complexity to operate end-to-end, multi-domain, with a single sort of operational model, the infrastructure to deliver a microsegmentation service is actually staggering. No customer I've seen, and I talked to more than 200 customers over the past 10 months while working on this technology, has deployed this really technology end-to-end. It exists in pockets, maybe in the data center, in campus, but very hard to deploy. The pros or the advantages of a switch-based approach is that it's always wire speed and it's agnostic to the endpoints. So it can work on a small temperature sensor in this room or on a big mainframe in a data center or on a virtualized workload. So the switch-based technology has some cons, but also has some limitations. And one of the most important limitations is that it imposes sort of constraints the way you build the network. You need to use certain encapsulation to carry those tags, microperimeter or microsegmentation label information. And you cannot really stretch that model anywhere in the enterprise. You still have legacy network. You need to interoperate, multi-vendor network, and bookending with a single technology, a single overlay, a single way of tagging is actually very, very complex. Of course, it's deployed, but it's very complex. And all what we're trying to do here is simplify, simplify, simplify. On the host-based side, again, those are agent-based, hypervisor-based. You can lump them all in, but I'm making some generic statement. They're highly optimized for data center workloads, right? They rarely exist in a context of an IoT or an enterprise, right? There are enough agents on laptops for IT, but there are no actually microsegmentation agents. Of course, it's possible, but not very popular. So I call them optimized for data center. The beauty of this technology, they're extremely sophisticated in the way they describe the applications, something we want to aspire to be as well. And the beauty also of this technology is that they are independent from the network, right? You can deploy a service irrespective of the sort of network topology, layer 2, layer 3, underlay, overlay, you're deploying in the network. However, the challenge universally when we talk to customers, limited portability. Even in a data center, you cannot place agents or custom hypervisor on every endpoint, every workload in the data center. There's always maybe a 10%, 20% that are left off. That's a weakness. And the other point is the cost, operational complexity. Now you need to manage, instead of let's say, a bunch of firewalls, a few firewalls, you have to manage a firewall per host, potentially, right? So operationally, it costs a lot of money and it's extremely complex. So how do we plan to do better if this is the landscape we're inserting ourselves into from a competitive point of view? Well, we want to take the best of these two approaches, meaning we want to preserve our ability to be wire speed, independent of any endpoint, build a technology that is delivered irrespective of the network, meaning you can build the network any way you like, and it's actually also a multi-domain technology, meaning we're going to have one operational model using CloudVision and EOS, right? We're not changing anything here, from campus to branch to data center, from the smallest IoT device or OT device in a factory to the largest virtualized workload in the data center, one operational model. That has never been done before. And we want to use the network because the network is effectively connecting every endpoint. We're in a unique position. Agents cannot be put everywhere, right? But the network is everywhere. Now, this is really what we aspire to do, and I'm going to show you briefly how we do it. This slide, I have to sort of go really fast. I'm going to just use this slide to bring two concepts. Number one, our labels are completely independent from the network data plane. Completely, are just tags that are locally significant inside the switch to do enforcement, but they don't exist in the packet. As a result, we don't require any special transport, underlay, overlay. In a switch, this is fairly unique and fairly, at least compared to the other implementation. And then, because the tags are locally significant to the switch, we can now describe, like host-based firewall technology, a workload or an endpoint with multiple tags. So you don't have a virtual machine that is a web tier, for example. It's web tier of a specific application, HRM application in a specific environment, for example, right? Very classic way of describing application used by many microsegmentation technology delivered on the host. All these concepts are now delivered in a switch form factor for the very first time.
You're tagging prefixes local to the switch.
Yes, okay. Yes, and EOS has a magical control plane, which based on the policies, it's really unique. It's able to synthesize these labels that come from an orchestrator, right? ServiceNow, vSphere, a NAC system, right? These labels are translated by EOS into machine-readable labels, usable labels, and then we enforce policies using TCAMs, but using actually these labels inside the switch. So it's a very powerful approach. I'm going to skip this slide. I'm just going to say that because we actually don't touch the network, you can define your firewall zones, your VRFs, your VL infrastructure, and terminate it on gateway without any constraints or requirements, right? We operate this service completely abstracted from the network infrastructure. Although we do enforcement in the network, you define your zone, firewall zone, your network zone, your VRFs, and then inside the firewall zone, we operate only on east-west traffic. And our policies are very simple: source group, destination group, or a combination of source and destination groups, and of course, a layer 4 service. So we stop at layer 4 like much of the sort of switching solutions available out there, because we go wire speed, so we cannot go very deep. Now, let me show you, the idea here is to show you also a demo. So I'm going to go through a demo as well. Maybe I cannot complete it, but I want to give you a sense of how you deliver this. We call it MSS services because it's not just enforcement. Enforcement doesn't get you zero trust, actually. There are two main challenges when a customer comes to us and say, I want to actually bring or implement a microsegmentation service. First, customers or organizations need to understand clearly who is who in the infrastructure. They need to have a mechanism to connect CloudVision to their single source of truth for their identity databases, meaning they need to define the microperimeters. Yes, you can use CloudVision and sit there and manually associate these IP prefixes and networks to labels, but what we want to do and what we have done is integrate with multiple identity of context and identity sources for campus and data center, right? So we have the ability now to tap into single source of truth coming from, for example, our own NAC system called Agni, Arista Garden for Network Identity, but we're also open and integrating with external NACs. And this doesn't stop just to groups or identity information. You can actually use, for example, Forescout iSegment to push policies. So we have API, open API in CloudVision, so we can integrate also with external policy orchestrator. We want to build not only at the network level, the the most open system, but also the orchestration level, defining the microperimeter, defining policy, also in external system. So we have GNMI and REST API northbound to actually push from this external system, NAC system, policies in the network. And then in the data center, you can see that, again, we're going to expand. That's what we have now, that the product is generally available with integration with vSphere, with ServiceNow, with Infoblox, all API integration with generic CMDBs through CSV files as well. So that's step number one. Step number two, what is the second step, the second biggest challenge of any customer thinking about deploying microperimeter segmentation? How do I build the rules? And typically, the way they build the rules, they require, let's say, a full view of all the conversations in the network. So how do we offer this service without any agents? Because I don't want to touch any endpoints. Otherwise, I break my value, right? My value is to deliver a service that is agnostic to every endpoint. So no agents, no software. So for that, we have devised a solution, and hopefully I'm going to show it to you. But at a high level, we have the ability to define which traffic while it's forwarded or dropped, is capable of being also mirrored to an appliance that runs EOS, our own EOS. This is a physical or virtual appliance. And this virtual appliance gives you firewall-style visibility of all the flows in the network. So you don't see flows, you see sessions, you see conversations. You have a stateful awareness of who is initiating the conversation, who is replying, how much traffic has been exchanged, has the communication been completed, so that when you build the rules, the information you're using is as precise as possible. You're not declaring a rule because you've seen a random flow. You've seen a full session exactly like you would do in your firewall, right? In a firewall, traffic goes through, you see the session, you can block it, but you see the traffic at the session level, right? So it's very, very important. So day one, we give you the ability to map all the conversation in the network, right? And I'm going to show you how to do it. It's actually extremely elegant and extremely simple. Our job as users is simply to sit there, validate the rule recommendation. We have something called Policy Builder in CloudVision. You're going to see in a second. We just sit there and validate, I trust this traffic, I don't trust this traffic, and then you push a rule with really the click of a button. And these rules are contextualized, of course, using all the label information, right? Once you push the rules in the network, right? In the network, I'm going to skip the firewall discussion, but we also have the ability to redirect traffic to external firewall, existing firewalls. Normally traffic that would be inside the zone, but if you want to apply a layer 7 service, I have login, some capability we cannot do at the switch at wire speed, we actually can redirect traffic to a firewall. But anyway, let's, this is actually a complex topic. Let's talk about then what happens after you have pushed your rules. After you push your rules, you can continue monitoring your infrastructure because the population of endpoint and services may change. So you still need, once you push your rules, to still monitor, to learn constantly and continuously, until you refine your rule set to a point where you're super satisfied and say, this is great. I'm now ready to turn on zero trust. And what does that mean? That the very last rule you deploy, instead of being sort of a forward and monitor the traffic, is going to be a zero trust rule that denies all the traffic not enabled by the policy matrix we have defined, and then monitor every packet drops from that point on. So if there's any violation to the policy rule, I can potentially adjust the rule set, right? So we call it segmentation for zero trust because we are implementing 3 key principles of zero trust architecture. Number one, we minimize lateral movement, right? Now segmentation is all around identity and context, and we have all this vast set of integration with external databases for identity. Second, we give the customer, the organization, the tools to build the zero trust rule. What is a zero trust rule? It's a rule that explicitly allows only the traffic that is trusted. But to do that, you need to see the traffic in the network. So without this visibility that we provide, stateful firewall-style visibility, there is no zero trust. It's all guessing. You end up breaking application. It's very complex to build granular policy without this level of visibility. And then once you deploy a zero trust matrix, meaning you're locking all the conversation in the fabric, in the network, we need to always be able to monitor the traffic we're dropping so we can adjust and update the zero trust policy. Those are actually very canonical concepts. You can find them in our competitors, but our competitors, they need agents, they need supplemental devices, infrastructure. Here is all organic from CloudVision. The only thing you need is another EOS device, right? Physical or virtual. It can be our Cloud EOS or can be this appliance for performance reasons to allow you this deep firewall-style traffic visibility.
So
and then now,
just a question on this then.
Yes.
And, Bob the Couch. So how do you address modern workloads, meaning VMs, but also container workloads, hybrid workloads?
Yeah. So right now this solution works for IoT users, anything on campus branch, and then in the data center, bare metal and virtualized. Right. We have no containers because for containers the challenge is the changes in containers are so fast, we would need a CNI and operate the enforcement down at the host level.
Right.
And we have not built that technology. Right now, we are an equivalent of sort of a switch-based microsegmentation. So there is no container support and there's no cloud support for now. Those are on our future roadmap. This product has been released actually just now, recently. So we're actually building it up as we go. Okay, so I have a very elaborate demo, but I have only 20 minutes here. So maybe I'm going to skip a few steps. But I want to show you at a high level. Right? There are these 5 steps: defining the microperimeter, building the rules, refining the rules, and then eventually turning on zero trust and turning on zero trust. So I'm going to show you these 4 steps just to describe my logical demo environment. It's a couple of data centers, and I've divided everything in 2. So it's awfully easy to follow. I made an attempt to radically simplify. We have 8 workloads, right? And they're divided into 2 environments. Sorry, let's go from the inside out. In 2 application tier, web and backend, 2 application, app 1 and app 2, and 2 environment, prod and dev. So you will see that we have a production environment, a development environment, 2 application, each application as a front end and a back end, okay? The microperimeter are completely orthogonal to the location of the endpoints in the network. They can be the same subnet, across subnets. It doesn't really matter. I wish I had more time to show you all these details. Oh, now, to show you sort of the diversity of data sources that we can use to generate or build these microperimeters, what I've done is something super simple, hopefully. The production environment, the tags come from ServiceNow/Infoblocks, but I removed the Infoblocks here, and from vSphere, and the development environment tags, these 4 virtual machines at the bottom come from vSphere. Okay. I had a beautiful exercise where I can show you that this tag can be dynamic, right? Meaning you can attach an endpoint to a tag, but I don't think I have time. However, what I'll show you is how these tags are stored in vCenter, and what I mean by that. And for example, here is, actually, let me give you another sort of something to follow here. So anything from 201 to 206 is production, from 211 to 214 is in development in terms of last octet of the IP, right? So when I talk about here, right, this is our 211, so this is part of development. And as you can see, it carries 3 VM tags. Those are the tags that we send to our CloudVision. You notice that there is no correlation with the port group, meaning the VLAN or anything at the network infrastructure. Those are just tags. And there are multiple tags that we can actually leverage now to build our policy, right? So I have a similar example here. This is our ServiceNow. We have actually the production environment. We have the application tier, web and backend, and we have the 2 applications. Right? I can remove tag. This was meant to show you an exercise to add and remove tags as well, but I'm going to skip that. Now, how do I build this connection? You go into CloudVision. Up here, you have something called group sources. And in group sources, if I click here, you have a ServiceNow, and then I have vCenter. This vCenter 8 is really this actually vCenter I'm using right here. And we build a connector. I can show you quickly an example of how a connector looks like described in YAML language. Fundamentally, you have the URL of the 2 services, ServiceNow, and in this case, the IPAM system, and then you have the credential, and then you have to describe sort of the type of tag categories you are importing, right? It's that simple. It's a YAML configuration that is very easy to generate. Once you do this connection, you go into the network into the MSS manager. I click on policy manager and click on groups. And here you can see, actually, let me see right here. You have ServiceNow and VMware. Those are the different sources, right? And vCenter. And those are all the tags that I've imported. Web, prod, web development, backend. And you see that they have 2 backend and 2 web because one comes from ServiceNow for production, right? And one comes from VMware or vCenter. If you click on any tag, you can see the members, right? The virtual machines associated with it. And right now they're not used in any rules, right? So this gives you a sense of how we import the tags from an external system. You have a NAC system, it will behave similarly.
Do you support other hypervisor environments besides VMware?
From a tagging point of view, yeah, hypervisor, I would say yes. From a tagging point of view, we rely on ServiceNow if you have, let's say, Hyper-V right now.
Okay.
By the way, Hyper-V doesn't have the vSphere tags. vSphere tags are quite sophisticated, but they're not in every system. They are in OpenStack, in KVM, with Red Hat is possible. But right now, we actually support only the tools I've shown you at the top, right? And we have OpenShift and other coming.
Hopefully you're working on that because obviously a lot of enterprises are evaluating their future.
Yes,
with respect to Broadcom.
Nutanix is a very popular
request. AHV and Azure Stack are the two that I'm seeing a lot of customers talk about.
Exactly right. So we have to expand, right, for sure, no question. All right, so now, what's the second step? We want to build the policies, right? So how do we build the policies? So to build the policy, we want to now redirect traffic to the appliance so we can actually understand what the appliance is doing. All the different conversations. So what I've done here, I went to the rules for the internal network, right? And what is the internal network? Internal network is nothing but a tag I have associated with these two networks, the 10.196/21 and the 144/20, right? So I tagged these two networks as part of my effectively internal zone. And then I've written up a rule, right? Part of the policy, which says internal to internal, forward and monitor, right? So you can see that if I click on, let's say, for example, the internal tag, internal is the combination of these two networks, right? It's just a tag. Now, every IP prefix is a tag, and I can compose rules extremely simple with that. And I created this tag, I created this rule, and then I have a traffic monitor object. What is a traffic monitor object? It allows for a secondary action. Not only you can forward drop the traffic, you can encapsulate in a GRE session the traffic and send and mirror the traffic to this appliance, physical or virtual. Let me show you quickly what is interesting about this device. It's a traffic monitor object. This traffic monitor, as you can see, is a tunnel destination. So every top of rack, in this case, builds a GRE session with the central appliance and uses this GRE session to mirror traffic over it. And notice also this traffic is truncated because all I care is layer 4 information. I don't need to see the full packet. I want to optimize the bandwidth on the network. So we truncate down to 256 bytes. And I also have the ability to enable a rate limiter. You see, this is all optional, of course, but I'm going to show you the configuration so you see how we can have some basic traffic conditioning, because now we are redirecting every single packet through this appliance. This is not flows, this is full packets. We are operating from a visibility point of view similarly to a firewall. Now, because I have this rule in place, internal to internal, what happens? In the policy builder, and when I go into the policy builder, it says that I'm collecting sessions. There is another collection for another VRF, right? Let's forget about this. Let's focus on the top one, which is our internal zone or internal VRF, right? So this thing is telling me that I'm collecting traffic. Now, because I was late, what I did is I launched some traffic already, right? So what I've done is actually this. I've generated traffic. Let me go full screen so you see better this slide. I generated 9 sessions. 9 sessions. There you go. There's a little bit of delay. I generated 9 sessions between all the endpoints and workload in this infrastructure. So basically, I have up 1 talking to up 2, up 2 talking back to up 1, but it's not something I want. And then every app front end talks to the back end. I have one flow that from development to production, right? Which I don't want. It's untrusted. It's red. Everything else is green, right? And I will create some policy according to this. I'm going to come back to this as I create the policies, right? But fundamentally, what I've done is generated this 9 session, number 9, and those are the 9 sessions I've generated. We're using a script written in Python Fabric. There you go. It's the script. And this script effectively connect to every endpoint, generates netcat traffic. So we have full stateful traffic, like a real socket between VMs, passing traffic. And we actually collect the results, whether the connection has been established or not. The tools tell you. So if you see any drop traffic, we can actually detect it using this tool. Now, I've launched a couple of sessions while we were waiting, and now what happens? Now, those are the 9 sessions that are collected into our session database of the policy builder. And as you can see here, we don't see the flows. Those 9 sessions are actually 18 flows, right? A client request and a server response. Here you can only count 9 sessions. Those are all the 9 sessions you have seen in my terminal before. And there is a directionality information, right? If the session is complete, means look at the last column. Next to the last column, the session is complete. It means that there was a response. So it detects the statefulness of the traffic. Then it gives you some volumetric information around the traffic, forward and reverse, right? And then, of course, you have the destination port. If the connection cannot be established, maybe because the traffic is blocked, the server is not responding, you're going to actually have a half-open connection, right? So once you have this information, then you are in a position to say, oh, okay, I want to create a rule for this, but I fully understand the context of this conversation. And to do this, we need to see every single packet, although truncated, on this appliance. That's when I said it looks like a firewall. It's not exactly like a firewall, but it gives you some stateful awareness of the traffic, UDP, TCP, ICMP, for all the sessions. Now, one other thing. If I launch this traffic one more time, maybe I should have done it earlier. You see that I have a counter 2, because this session has been established twice. So this communication, I've seen this communication twice, but I'm not sending you another record. I'm aggregating on a single line by incrementing the counter of complete or half open. I'm incrementing the counter of the session. I'm sending now more traffic, so you should see actually this session count increase and this complete go up. So this is actually a very powerful aggregation. It's not just a flow visibility. It gives you an aggregated view of all the sessions. Our goal is to construct very precise rules, which is my next step. You see that I'm ingesting some of the new traffic. I should get to 27 when everything gets pushed via IPFix into CloudVision, okay? So now, let's not wait for this. Let's jump into the rule generation, right? I'm gonna then maybe break it after that because I'm not sure we're gonna have a lot more time. So, how do I generate the rule? I've collected the session. I have the identity that comes from ServiceNow and the CloudVision. Now, what do I do with that? This is where it's really interesting. So, before I generate the sessions, CloudVision is asking me, which labels do you want to use, right? So let's actually go back to our zero trust mandate that I had laid down in the slide. I'm flipping quickly here, but it takes a little bit of time. So what I want to do first is the following. I'm going to construct these rules simply. First, using 2 basic rules. First, I want to block anything that comes from development to production. So I don't care which application, so I want to just use the environmental label development and production. I don't care about up 1, up 2. Any traffic from dev to prod needs to be blocked. And then I want to allow every communication, TCP or UDP, as long as I've seen it, I want to allow that communication and only that communication explicitly, right? The keyword here is explicit. When zero trust is all about explicit rule that let the traffic through. And then I will want to create very granular rules for the production environment. But I want to show you that we don't have to do everything day one, right? This doesn't have to be a daunting task. I can take it in steps. I have my flows in the database. Let me first create the basic rules, meaning in development, I'm going to let everything go through, and in product, I'm going to block development to production. Production, I'm going to worry about that tomorrow, right? And hopefully I have time to get to to the example. So how do I do that? Boom, let me go back. So here I'm selecting the environment label coming from ServiceNow production, as I said before, and then I have an environment label coming from vSphere. Right? Maybe this will be complicated because I have two sources, but fundamentally I only care about coloring the session database only with the labels called, or the label category called environment. So what is my intent here? As I said before, development to development, I'm auditing now the traffic. I'm going to forward. I'm not going to change to drop. Prod to prod, prod to prod, prod to prod, these three services, I don't care right now. I said I'm going to focus on that later on. Development to development, I want it. Development to production, it's a no-no. This is a bad actor or somebody misbehaved. I'm going to drop this traffic, right? Here you can also visualize sort of the conversations in a bubble format, right? You can see the number of services we're using and the label-to-label representation of effectively these rules, right? So, and then let me show you something here. If I want to see, okay, you're telling me that you're generating this rule from dev to prod, but what actually sessions are you using? So I'm clicking on the right-hand corner, and this thing tells you I'm generating these rules because 211 is talking to 205, right? And 211 to 205, I know this is hard to follow, but if you look at this thing, 211 to 205 is this connection number 9. So there you can see the connection, right? And you can see how I've used the connection in the database to create this rule up here, development to prod. And then I've decided that is not trusted traffic, I want to drop it. And now what happens? The same thing, oh, I'm sorry. Okay, then I pushed submit, and with the click of a button, now you can, yeah, sorry about that, there's some lag. With the click of a button, you can see the same quick action that Paul has used, right? We automate the full change control to push actually rules into the network, right? And now this actually is programming the 7 switches that I've shown you in the 2 data centers, right? It goes through a change control, all the validations, all the auditing is also possible and stored. And then my next stop is validate that I've sent correctly, set up the rules correctly. So I'm going to relaunch the traffic. Looks like we have executed this. Let me relaunch the traffic. Hopefully I use the right password. In the meantime, let me show you in the policy managers the rules that I've created. I've created actually these 3 rules, right? And see how they sit now on top of the last rule. So what is happening now? The traffic that is not hitting these rules is going to hit these rules here. So what this means is that now the traffic from session 9 dev to prod is dropped in the network, is not going to get monitored anymore. And all the traffic inside the development environment is not monitored anymore. So when I relaunch my 9 sessions, I only have the production traffic now showing up on the appliance. And now I'm ready to refine my rules and get to the next level. And this is how I will close sort of the demo. So let me actually go back to the policy builder. If everything works really well, as I expect, as it always does, I only have 5 sessions. Right? Those are the 5 sessions from 202, from 201 to 206. There's no 211 here, right? And now I'm ready to refine my policies. And let me do this. Now, we want to create the policy for the production environment, right? So what do we really want to do here? Policy for the production environment is only these 5 flows up here, okay? So how do I do that? I need to get into the labels coming from ServiceNow. ServiceNow has an environmental label, an application tier, and an application code label. And I've asked him to generate my rules. Right? This is all done. It's just taking time here. Right? There's a huge lag, but I have all the rules here. Beautiful. Now, let me zoom in a little bit more. Okay, so you can see. Now, what do I want here? I said it at the beginning. I regenerate the rules because I forgot a label. Environment, application tier, and application code. Up 1 and up 2, web and backend. Oh, I use VMware label, I'm sorry. and then up code from ServiceNow. There you go. There you go. ServiceNow, environment, up tier, and application code. Generate. It doesn't, there's a lag here, but it doesn't take the regeneration here. Anyway, I think at this point, we should have seen, yeah, it doesn't take the regeneration. Yeah, for some reason, it's stuck. So here, now I can create, though, I have the 5 flows, 1, 2, 3, 4, 5 at the top, and I don't have the right label now. It didn't regenerate me with the right label. But now I'm in a position to deny the traffic or allow the traffic explicitly that I want, and then I can push the rules. If there are sessions that I don't want, for example, application 2 talking back to application 1, I can actually explicitly block that traffic, right? So and then I push the rules into the network. So from the visibility, we build now the rules and we push them into the network without any guessing game. This is really based on the observed traffic. Yes, you can always build rules top down, but the beauty of this system is that without any agents, we inspect all the traffic and we can create rules from to get to really a zero trust environment. And the last step is to turn on the last rule from forward plus monitor to the deny plus monitor, right. And then you have zero trust.
One very quick question: are you able to add comments or tags or labels to the rules themselves to identify?
Yes, we then can go in the backend system and modify the rules, apply a description, and reorder everything. Yes, this is all possible as part of the system.
Observation, which is that this is great for demonstrating the very fine visibility and detail.
Yeah.
However, I'm thinking if I were a network admin looking to start out, this suggests what I think of as Cisco tetration problem of just too much info. And what I would want to do is probably create some very simple rules of this group, these addresses or whatever can talk to these addresses.
You
and
can
then
do that.
refine later.
Absolutely.
Yeah.
You can do that. I showed you the bottoms-up approach,
Right.
building the rules from the network, but you can programmatically go there and program basically, for example, dev talk to prod, probably you don't need to see the traffic, but at least you're now, you're in a position, hey, I'm going to deploy this rule. Let me call this guy that I'm going to break his applications, right? Because now I'm deploying a rule. So you remove the guessing game, and you're not going to break any workflow before you deploy a rule. And you can first investigate, detect what's happening, inspect what's happening in the network, and then deploy. So it's a different way, but totally your method works as well.